Right. So, in our journey to understand electrochemical cells, we have had a look at how we can put two half cells together to create a cell that will have a voltage, a potential voltage. We can measure that with a voltmeter. We have had a look at how we can represent that with a cell diagram, so we don't have to draw a picture every time that we are doing this. And using our states of matter, having our anode, then our bridge, then our cathode, and any solutions involved in the middle. The next step for us was to find out that actually each of these cells, when measured against the hydrogen cell, the hydrogen half cell, have got what's called a standard electrode potential. So that's given the symbol E with a little zero at the top. The reason it's got the little zero is that these are done under standard conditions. Solutions are 1 mole per litre. If there's any gases involved, they're maintained at 1 atmosphere. And any metals, any solids like electrodes are pure substances. And of course, the other one is at your 273 Kelvin or 20 degrees Celsius. Okay, so 278, my apologies, 25 degrees Celsius. You don't need to know that. That's just some background as to why these numbers are the same in any textbook, anywhere in the world, because we keep these standard. The little zero means standard conditions. So when we put zinc with hydrogen, it gives a negative voltage, negative 0.76. That means that being a low number, it tends to be oxidized. So the lower numbers tend to be oxidized. Higher numbers, anything above zero, tends to be reduced. When I put these together, that is exactly what I observed. The zinc is being oxidized, so our electrode would get lighter and lighter and lighter if we weighed it. And my copper either will get bigger and bigger and bigger, or there'd be some copper collecting at the bottom of our beaker. We also are going to get a voltage, and I was very happy when I got a voltage just over 1 volt when I made this for you in class. And now I'm going to show you why I was so happy about that. It's what I hoped for. I was hoping for 1.1 volts, and we got pretty close to it. And that's the bit I want to do in this video. So, with these two half cells, I can calculate or predict, if they were under standard conditions, what my voltage would be. I do that because I know these two numbers here. I take my right-hand side and I subtract the left-hand side for these two values. So on the right-hand side, I've got 0.34 volts. And I subtract negative 0.76. I don't change the sign for it. I subtract negative 0.76 volts. If I do that in my calculator, I get a positive value. I'm hoping my mental arithmetic is right here, of positive 1.10 volts. If this number is positive, so above zero, then it creates a voltage. It works. It works in the way we've drawn it. Reduction over here, and oxidation over here. If I get a negative value when I do this, it means that I drew it the wrong way. I actually set it up, I drew it wrong. So if I don't get a positive value, then I've drawn this back to front, because a negative value means the electrons are flowing the opposite way, which is why we get a negative voltage on our voltmeter. So if I end up with a negative number for this, all it means is I have to redraw this the other way around. This calculation is our key thing we do whenever we make cells or batteries to be used in appliances. We want to make sure it makes an appropriate amount of voltage for that appliance to work. So for example, an AA battery with the chemicals involved gives 1.5 volts because of the concentration they use and the chemicals they use. It has to always give 1.5 volts because it's ratios of 1.5 volts that make our appliances work appropriately. A 9-volt battery is quite different again. It's got different chemicals in it, and it has to be 9 volts with the combination of things it's got. Now, it doesn't make 9 on its own. It's got a series of them in a row, which add up to 9. So what do you need to get out of this? Well, when you're given these electrode potentials and you're given a cell diagram, you need to be able to work out what the voltage is. The rule, as it were, is you go the right-hand pair, whatever their voltage is, minus the left-hand pair, whatever their voltage is. Right? If you get a negative value, do two things. One, check your maths that you've actually done it right. So minus a negative, for example. If that's correct, then you can infer or suggest that the battery has been set up back to front, and you have to swap those two cells around to make it correct.